factoring using the greatest common factor, example number 1. So it says, find the GCF, which is greatest common factor, then use an area model to factor the expression. So we have 6ab minus 8a squared. Does this look familiar to you guys? 6ab minus 8a squared? We just factored that in our opener, right? So I'm going to quickly jot that down as you guys quickly jot it down on your papers as well. Now, if you write big like I do, you want to make sure that you're giving yourself room on your paper to make an area model and a factor, okay? So if you write large like I do, kind of make sure that you're leaving yourself some extra space to create an area model. Okay, so then from here, I'm writing out my lists, just like what we did on our opener. And with this information, I'm able to find that my greatest common factor is what? 2. Okay, so they have a 2. And what else do they have in common?
I don't know why I said 3.
I don't know either. I think because you're thinking of the factors, the prime factor. An A. Good job. All right, so my greatest common factor is 2A of this expression. So the first step that I'm going to ask to see on you guys' notes is the factor. Okay? From here, we found the greatest common factor. What's my greatest common factor?
2A.
What is this going to represent on my area model?
Height.
The height. Good. So if you remember in our opener, the back, once we factored that, the greatest common factor became the height on the area model. Now, this is my area, and we know that this is the area because there's no parentheses. Now, if we had parentheses, we'd know to represent the height and the length. Because this is the area, how many rectangles will I have in my area model?
2.
What was that?
2.
What is that?
2.
2. Much better. All right, so this is where we're going to draw our area model.
That sounds like cheating. That looks like cheating.
That's called perfection. You like that? It is cheating. If you saw me try to draw a straight rectangle without the ability to have a shape, it would not be pretty. Now, because I have 2 areas, what kind of line do I have to draw on this rectangle? Which is a vertical line, right? See, Hannah, this won't be it's not as solid. Okay, so let's start labeling it. What do I know about this area model?
2A
Is very good. So my greatest common factor is my height. So 2A is my height. Okay, what else do I know about this area model?
Would 6AB be what it equals?
Which is the
The A equals?
say a little louder.
area.
The area. Yeah.
Couldn't remember what it's standing for.
That's okay.
A equals?
What's the area of my last rectangle?
8.
8B
You're so super.
8AB.
That's negative.
Say that again, Riley.
Negative.
Take that negative with it. So this is where we had to pay attention to that negative. We got to take that negative with it. All right. So what are you guys trying to find? This is just like the opener, right? You only had to add one more new step into the learning process today. So we're trying to find the length. To find the length, I take the height times something to get the total area. So the height is 2A. All right, Jenny, you've been super quiet over there. 2A times what will get me to 6AB? So you can break it down and think about your coefficients first. So 2 times what gets me to 6?
3.
Perfect. I have an A in my height and an A in my total area. Does my length have to have an A? No. I have a B in my total area. No B in my height. So what's my length going to have? 3B. So the length is 3B. Okay? 2A times what gets me to negative 8A squared? What do you guys think? 2 times what gets me to negative 8? Negative 4. Now we have to worry about our variables. I have an A in my height. I have an A squared in my total area. So my length needs what?
A squared.
Now, I want you to think about that. If it needs an A squared, if you take A times A squared, remember A has an exponent of 1. So what's A1 times
Wait,
A2?
You don't need that too.
You don't need the 2 because that would be A to the third. So what would I need?
Just leave it as just negative 4a.
Just leave it as an A to the first, right? And if it's just A to the first, I don't have to show an exponent there. Good. All right. Now, I have my area equals, I'm not quite done because I have to write my answer now. So my area equals what?
I'm not sure I understand.
I hope you guys understand.
I do.
Okay, show me, tell me.
What was the question?
Oh yeah, you said you understood. So now I need to write my final answer. So I have my area equals,
Oh, A2A,
which represents my,
height,
okay.
parentheses,
Why are you doing parentheses?
so I can put the length in there.
To show what operation?
Multiply.
Okay. Okay, so 2A times,
Repeat. Minus 4A.
just like that?
Yep, and you gotta put in our barrier.
So in parentheses and box it to show that that's my final answer.
I did complete opposite. After that, it equals 2AB minus AA3.
Yeah, I wrote the whole thing out the first time.
That's fine. So you could, okay, so you just wrote that. Yeah. What we'll do, we'll just put our answer right up to the right of where we put our example problem. What did you do?
Oh yeah, I did this.
I did, 2A. That's fine as well. Just to make it easier on yourself, just write it right up to the right of where we put our example problem though. It's the same thing, okay? You're fine. Any questions on this? All right, thumbs up if I gave you a quiz on it today, you would be able to get an A or a B on it. Thumbs in the middle if you get a C on it. Thumbs down if you would probably not do so well. Okay, all right. Here we go, let's fill in some blanks. Let's get some of our notes down. So let's look at our steps here. So think about the example problem that we just completed. With the example problem that we just completed, get all of it? With the example problem that we just completed, step 1, we determined the blank of all terms in the expression.
Variables.
What did we determine? The greatest common factor. So determine the greatest common factor of all the terms in the expression. Step 2, after we found the GCF, we drew an appropriate area model with one blank for each term in the expression. One square, one rectangle. All right. When we did that, we then moved on to step 3. Step 3 said to put the greatest common factor on the blank of the rectangle. So what was the greatest common factor? What did that represent on our area model?
The area?
What did the greatest common factor represent on our area model? Look at your paper.
The height.
Yeah, the height. So if you look where you found the greatest common factor, you then made it the height on your area model. That doesn't look right.
Height.
H-E-I-G. Was that right?
What, H?
G-I-G-H-T.
That just seems like
H-T. Not
I'm having H-E-I-G-H-T. H?
height.
I'm having issues. Help me out here.
Vertical
That's
length.
right. So G-I-G-H-T.
Okay. Woo. Thank goodness I'm teaching math and not spelling to you guys. All right, step 4. So after we put the greatest common factor on, it's the height of the rectangles. Step 4 is to complete the length, which would then complete the area model. And then the last step, write your answer. All right, once you have that down, go ahead and flip to the back side. We do have 2 more example problems that we're going to accomplish today, okay? Did you get them all down? Area model. All right, go ahead and write this one down. It says factor using the greatest common factor. Now you're probably going to want to write this example problem up in the upper left-hand corner, right under example number 2. You have 45, c to the 4th, d to the 2nd, minus 27 c to the third d to the third plus 54 c to the second d to the sixth. So after you write down the example problem, as I'm looking around the room, what should I see you doing? Maddie started it, starting the problem by doing what to it?
Finding the greatest common factor.
Yeah, so what I should see is you guys finding the factors of each term in order to find the greatest common factor. All right, Jenna, will you work with me while they're working on their papers right here? 45.
9 times 5, and then circle the 5, and again, multiply 9 by 3,
Okay. 27.
and then 9 and 3, circle to 3, go down to 9, and put 3 and 3, and circle those,
Okay.
54, and 9 and 6, go down, and it'd be 2 and 3, 3 and 3,
All right, so I'm going to go ahead and make my list over here to the left to see what they have in common. All right, Danny, it looks like you have this step down. Tell me what they all have in common here. What should I be circling that they share?
2 3s.
Okay, so they share 3. And you said they share another 3. So my greatest common factor is going to be, okay, because we take 3 times 3 to get 9. Then let's look at our variables.
C2
Okay,
and D2.
good. Any questions on how we came up with the greatest common factor? Okay, so, yes.
How do you get 9 times 3 and 3?
There's another 3 that they all have in common.
Yeah.
So you would circle that. Then you take a group of 3 times the other group of 3, which would be
No.
9. Then they all have a C in common.
Yeah.
And we pick the one with the smallest exponent.
Yeah.
And then the same thing with D.
Okay.
Okay? Now, what does this represent on my area model? My what?
Area.
The greatest common factor represents what? My height.
Or height. Oh,
There you go.
ignore me, sorry.
That's okay. I can't spell height, so, I mean, I'm not going to ignore you. Okay, so I have my area model here. This time when I draw my area model, how many rectangles am I going to have? Look up here. How many terms in my expression do I have? 3. So I have 3 terms in my expression. So how many rectangles am I going to have? 3. That's right. And then as Maddie said, the greatest common factor is going to represent our height. So I'm going to go ahead and put that out there. How are we doing? Make sure, draw all your areas vertical lines. You don't want a horizontal line that, because that separates the height. So the height won't be 9 on that because you just divided the height. So you have to have them all vertical. Okay, good. All right. What is the area of my first rectangle? Logan, what's the area of my first rectangle?
Area of your first rectangle?
Yes, sir.
It is 45 C the fourth power,
Correct.
D the second power.
Okay. Second, I'm going to have you do all the areas. So what's the area of my second rectangle?
It is negative 27 C to the third power, D to the third power.
All right. And your last.
54 C to the second power D to the sixth power.
Nice. All right, so I'm ready to find out the missing length. So if I'm ready to find out the missing length, how do I do that? Jenna, I'm going to have you find the first, Riley the second, Maddie the third. All right, Jenna, so I have the height times what here?
5.
So 9 times 5 will get me to 45, okay.
Do that one is 5C squared.
That's it. Nice. Okay. So then I have the height, 9c squared d squared, times. All right, Maddie, you ready? So how do I find the length of my second area model? So 9 times what equals negative 27?
It is 9 times 6d to the fourth power.
Wait. I'm having you do the second one here. Did I say I was going to have you do the third?
You said me for the third.
Okay, Riley. 9 times what equals negative 27? Negative 3. Okay. What about for c's? Do I need any more c's in my length? If I have c to the second in my height and c to the third in my total area, my length, so I'm going from 2 to 3.
Yeah.
So if I'm going to 2 to 3, how many should my length have?
5.
You don't like this part, do you? Okay, so I have, that's okay. We're going to work it out. So c times something to equal c to the fifth, right? Okay, so do you remember how we talked when we multiply bases with the same exponents? We actually add them.
Oh, yeah.
So we know that my base is c, but if I'm going from 2 to my total, because that equal sign is 5,
Oh, 3.
bam, there you got it. Good. So, okay, so now if we're doing c to the second times to get to c to the third, what am I going to have? To go from 2
A 1.
to 3. So c to the first, do I have to show that 1?
Oh, no.
No. So good. So negative 3 times c. Okay, what about your d's?
Yeah.
What about, yeah? So I have d to the second to d to the third. So how many d's do I need?
1.
There you go. So my length is negative 3 c d. Good. All right, Maddie.
Okay, so I did negative c to the second power and d to the second power times 6d to the fourth power, and I got 6d. Well, yeah.
Do you guys agree with her?
Mm-hmm.
Any questions on how she got 6d to the fourth?
I divided it. I did 50.
Is that how you figured it out?
Yeah.
And that's completely fine. Am I finished with this area model yet?
No.
No. So I need to write my answer. Who haven't I heard from in a little bit? Hannah? Hannah or Danny?
You haven't heard from me yet.
How am I going to write my answer now? Hannah? Oh,
You took my opener away. Assuming I actually remember.
okay, so we know the total area. So think about the area of, how do we find the area of a rectangle? We take area equals height.
Height times length.
Okay, so what's my height?
9c to the second power. D to the second power.
Okay, so my height. How do I show times?
Parentheses.
Okay.
5c to the second power plus, or no, minus 3c d plus 6d to the fourth power parentheses.
And because it's my final answer, and we have a lot of work that we've shown, I'm going to go ahead and box that so it's easy for me to locate. How are we feeling about it? Okay, because we are going to run out of time, what I would like to see, I'm going to give you the last example problem, okay? Do you guys all have this down before I flip? Logan, you have it down? Okay, so here's your last example problem. What I'd like for you to do is write it down, start to factor it out, and solve it. Bring it to me, finish tomorrow, and if you have it correct, then you can earn a little something. Whether it's a piece of candy,
Pizza party.
huh? Pizza party for getting one question right?
I mean, that's all.
So then we'll go through it tomorrow.